Perfect. Okay. Sweet. Ooh. Hey, T, are you back? Oh, yeah. Are you seeing this stream? I'm telling you, folks, the oldest trick in the book, power cycle. It's actually kind of sad that this is such an effective mechanism. Like, have we really not reached the state that these systems, like, this is part of the reason why we have to have machine programming, right? A machine programming system, just to be clear, this is a simple fix. This is not a hard problem. The way it works is like this. And keep in mind, I've built some systems like this. It's just that Merle can't be everywhere at once yet. We're working on it. But the simple fix is this. After you establish the internet connection, the system itself does self-monitoring. So after some threshold of time, it reaches this sort of level of normality, and then you start to do sampling on the upload and the download speed. Once you get a sense of the approximate speed that you have, if you see something like what we just saw, which would be a 90% degradation in the fidelity, you just power cycle. You just like let the user know, hey, your internet's not fast. Like, can I power cycle it? You do something, right? Or here's one. When the user is not actively using the computer and you're able to monitor it, because, like my computers don't turn off, you can just do it then, right? That's often why your phone and your computer will do its updates at 3 a.m. Because, well, except for me and Taylor, a lot of people are sleeping at 3 a.m. For us, it'd probably have to be, well, for T, I think you just don't sleep. But people like me, I still need to sleep. And like, seriously, T, I don't know how you did that, because I think you were up until at least 3 a.m. last night. And then you were back up this morning at 7. I mean, I hadn't gone to bed yet. That's why I was responding to your text messages. I was still, yeah. You're up until 3, back. Man, that is crazy. Yeah, I went to bed, and I go to bed around 9 a.m. and I was up by 2 p.m. So I got 5 hours. And for me, 5 hours is plenty. Like, I'm not even in a full nootropic state. And so I feel fantastic. But I might also feel fantastic because the board of directors slide deck is done-ish, which cheers to you, T. That was lots of fun. Okay, cool. Yeah, I try on the weekends. I'll try to get, like, usually on Friday night or Saturday night, I'll try to get at least one day where I get 8 to 10 hours of sleep. Yeah, seriously. Major high five and love on that. You did an awesome job with that, as per always, T. Incredible stuff. Oh yeah, to move this down. So I guess I can move it to about here. What I try to do is one day a week, usually on the weekend, I'll try to get 8 to 10 hours of sleep. Yeah. And then during the week, because of the way I work, as long as I get 3 hours of sleep, welcome to the life of Goju. 3 hours of sleep is enough, as long as it's just serious REM. But I can only do 3 hours of sleep for about 3 days in a row. This is pushing it. So the first day, like, for example, I got 5 hours of sleep last night. I'm fine. I'm probably going to get more tonight, maybe 6 or 7, because the board meeting tomorrow. And since I need to have this working for the board, probably sleep more than 5 hours, I hope. But in full worker mode, 3 hours, I can do that several days in a row. But by the third day, I start to, like, things aren't working. So this is where I can tell my mental efficiency and my ability to sort of produce fully coherent thoughts it's starting to degrade. Like, I can still do it, but I can tell that it's just much harder to think simple things like, what is 4 plus 7? Like, okay. So yeah, 3 days in a row for 3 hours of sleep I can do. Fourth day, I must sleep more. But during the week, if I sleep 5 hours a night, yeah, I can do that pretty much every day in the week, as long as I have the catch up, at least 1 or 2 catch up days on the weekend. Yeah, that's approximately it. And now when I'm doing serious weightlifting and exercise and stuff, so I haven't been doing that as much because my shoulder is still recovering. But once I start doing that again, I'll probably need closer to 7 or 8. But I'm not going to be like, I'm 50 now. Okay. Like, the weightlifting days of 5 days a week, like, it was fun. It was a nice experiment, but 3 days is going to be good enough for me. So anyway, all right. I'm glad that we've got our stream thing going, and we've got this. Look, we have some viewers. By the way, people, feel free to chat. Okay, it looks like maybe this thing's doing better. And so now I was gonna talk about this stuff. Oh, and by the way, I decreased the font size. Hopefully this is still legible. What I've done is I've tested, I mostly just rewatch the GTT episodes on my TV. And what I noticed is that YouTube's streamed version, I can't make out the text with clarity in their HD version. But because I'm recording these in 4K, then when I upload the 4K version, I can read the text. So I was checking this out in the last one where we were looking at like the DOTSA code. And so I could read all the DOTSA code when it was in 4K. But I couldn't read it. It was like, and partially it's maybe my eyes, is I have, yeah, even though, oh, awesome. That's great. And so even though I had LASIK last year, you know, it's, if my eyes are tired, so this is the story with my glasses. I can sort of see-ish, but if my eyes are getting tired, this helps. It's like a 10% improvement. But before LASIK, you would never see me with my glasses off. So the big thing that I absolutely love is I can do exercise now without my glasses on, which probably doesn't sound like that big of a deal. But let me tell you, for those of you who don't wear glasses, when you exercise, especially when you exercise like I do, I sweat a lot. Or I want to go run in the rain. Running in the rain is like actually one of my favorite things to do. Doing that when drops of sweat or drops of rain are coming on your glasses is just kind of annoying. So I don't have to do that anymore. But coincidentally, to make this story even stranger, my new major hobby is my electric unicycle. And so now I can be on the EUC without glasses, and it is not helpful. It's the opposite of helpful, because I'm moving pretty fast, and the wind, as well as like insects and stuff coming, into my eyes. So when I'm on the EUC, I'm pretty much always wearing these or sunglasses or something, or the visor. Anyway, we're meandering here, but yeah. Okay. So initially what I wanted to talk about, as I was discussing with Taylor, is about more on synthetic data generation, why that's super important for machine learning, and how that's one of the key ways to build really just more effective machine learning, machine programming systems when you have some sense of the shape of the data that you may want to synthesize. And the truth of this is that most of the data scientists that I know, they tend to, this is kind of like what they do, right? So if there's any data scientists, I just am like a pretend data scientist. I don't have a degree or anything in it, but I sometimes teach data science. So, like I said, sort of pretend. But generally, data scientists will do things like they'll take this data and they'll look at it and they'll try to understand and try to get a sense of things like the makeup of the data, and do you have really good in distribution data? Is there any out of distribution data? Do you have issues with quality of labels? Do you have enough just general allocation of labeled data, if you have labeled data for different categories? Are you getting essentially good coverage in the quadrant spaces? So when you're building your system, you can have a stronger confidence score on just a wider range of data than you might have if you're only using the data that you are given with the data set. So a lot of times the data scientists and advanced machine learning folks will look at the data and they'll augment the data. So one of probably the most overlooked aspects of machine learning is in data curation, data augmentation. And I work with a lot of data folks, like we were looking at Stan Zdonek last time. He's very much a data person. Nesime Totbol, she's a data person. Just a lot of data folks. Tim Kraska, Morris Herlihy. And it is a little bit strange how the world is kind of like a little like overly in love with models right now. So it's sort of like model this, model that, all these models. And I think partially because it's like this shiny toy, and it kind of like feels exciting, but it's interesting because it's almost like excitement about the wrong thing, where, like, for example, as I was explaining with C++ or other object-oriented programming languages, it's my opinion that some of the key aspects that make classes and object-oriented programming so valuable is the idea of interfaces, right? That's what we were going to talk about, like these pure interfaces and abstract classes. And then the other idea of data encapsulation. But when OO first came out, there was a lot of excitement about inheritance. As we were discussing before, it's a more formal term, and I'm saying this mostly to train myself, subtype polymorphism. So subtype polymorphism, as I understand it, is essentially the formal term for like inheritance, or inheritance is one way to do subtype polymorphism. There's probably others. Parametric polymorphism is things like C++ templates or Java generics. It's when you abstract the type entirely and then you write some code that then there's probably some template stuff in here somewhere, simply because I tend to, I bet if we look at this scheduler, the scheduler might actually be subtype polymorphism, because I think I needed to do inheritance on it. What did I call this? Yeah, basic scheduler. Yeah, it's okay. So yeah, this is doing subtype polymorphism. There's a reason why I did it this way rather than through parametric polymorphism templates. But we don't have to. Oh, sweet. We have Mur in the chat. Sleep for yeah. Yeah. Mur, T and I are both massively sleep deprived. T more than I am, but we're here anyway for kicks. So anyway, yeah, this is an example of, as I understand it, subtype polymorphism, because we have this base class data generation scheduler, and we are deriving from it publicly and creating this basic scheduler. Subtype polymorphism. And then the parametric polymorphism, yeah, it's essentially this is our parametric polymorphism. Except we're not creating it; we're just using it, right? Hey, Mur. Yep, we got like at least part of the crew. If we get interpretable metaphor and like no code on here, we'll have like a full house of us, the constant nerds. I could have sworn I had like, it's really rare for me not to hack on some kind of template something. I'm actually quite surprised that I didn't do this somewhere. I mean, maybe I was trying to branch out. Maybe people were like yelling at me. Just have to look a little bit more to see if I can find one example, and then I promise I'll move on. Function variable, that would be a good one. That, yeah. And it, oh, okay. Random variable. Oh, what's happening? Okay. Hope these guys. Okay, we'll just reload. Whoa there. You've exceeded. Oh man, that's okay. That's well, the good news is we weren't actually going to look at that anyway. We were going to look at this. So there you go. We were going to look at this thing, and yeah, it is. And Slack's also acting really weird. So yeah, it's some stuff's going on. We're probably having some major DDoS. Yeah. Yeah. Ver/Mur, you should let us know what we should call you. Because I've just been going with Mur since that's sort of the abbreviated without the numbers. But if there's something else you prefer, let us know, since you're the topic of many conversations these days. Okay, so we were going to talk about this, and we might talk about this a little bit more, but I also want to talk about this, and I want to talk about this because I did a little experimentation, and I found some funny things that I want to share. Okay, cool. Maybe I'll switch in between. Yeah, you can also, people switch between Justin and Goju, although I think Goju tends to just be easier because no collisions. But I'll probably switch between Mur and Ver. Maybe I'll have one that's when I'm really upset with you. Ver, what did we talk about? So that's kind of how I am with yeah, seriously, get ready, break out the popcorn. This is gonna get wacky. It's how I am with the doggy. Usually I call him Merle. Hey Merle, hey buddy. And if I say Merly, Oh, he knows. The ears go down. He just like tail drops. Oh no, I'm busted. What did I do? It wasn't me. It was the other dog. There is no other dog, buddy. Okay, you scared them all off. All right. So I was just fiddling around with Mentor the other day, just looking at stuff, and I was looking at this repo, this gRPC, and this is part of CNCF incubating. You might actually know more about this. So if you want to drop in the chat, like what this thing is doing, just a little background, that would be. Actually, yeah, I am the other dog. Yeah, and sometimes he tries to fight for the alpha spot, which I'd happily give him if like he could run the company and he could teach at the university and all that stuff, but his jobs are basically sleep, give me the puppy dog eyes on all the food he's not getting, and he's getting plenty of food, and then to run around and bark at the neighbors so much that they text me and say, hey, and they all know his name too. Like, hey, so Merlin's going a little nuts here. Oh, sorry. He was doing it the other day, and it was when I was coming back from IBM Think, and it was kind of hot, so I pulled, dropped the windows down, opened up the doors and stuff, and he was in this like full puppy dog, like, oh my gosh, daddy's home, I gotta go crazy, I'm gonna whine and bark and I mean, like, and this went on for some time. This went on for a while. Now keep in mind, I'm just back from Boston, and I'm out of my mind. I'm thinking I'm like, oh, and I got to do a GDT episode. So I'm setting everything up. And so I'm paying attention that he's a little loud. And this is like 10 p.m. or something. But I'm not really paying attention. And so the next morning I wake up and, my phone was somewhere, but I'm not one of those people that kind of like lives by their phone, which some people don't love. But so anyway, the next morning I checked my phone and my neighbor was like texting me around 9. Hey, Noni, what's going on? Welcome to GTT. So my neighbor sent me a couple texts. They were very friendly, by the way. She's super nice. And she was like, hey, I don't know if you're home. Sorry to bother you, but if you are home, it seems like Merle, I think she actually calls him Merlin. Merlin is going a little crazy, and the kids are trying to sleep. And so I apologized to her the next morning saying, oh, no, I was home. And yeah, he was going crazy, mostly because of me. So it was actually totally my fault. So sorry about that. So I guess what I'm trying to say is my neighbors don't totally love me because, yeah, the doggy. Hey, Noni. Excellent. Sweet, my friend. Hello from Northern California. Yeah, love Bangladesh. Have actually several colleagues from there. Okay, so gRPC is, what is Taylor telling us? It's a Google Remote Procedure Call. Cool. Communication protocol designed for service-to-service interactions. Excellent. Particularly effective when building distributed systems that require high-speed, low-latency communication between services. Okay, excellent. Thank you, T. So now we have a basic understanding of gRPC. Now, many of you, I think, have heard me talk about the issues with stochastic systems versus deterministic systems. And so we discussed this, and yep, we all knew there would be a test. So not many people, I think, really were deeply paying attention to this because it was very academic, but this somewhat boring academic stuff is going to get real. in about 30 seconds. So the Merle AI system at its core is a deterministic AI system. You can build deterministic AI. It doesn't have to be a stochastic AI. And simple examples of that are linear regression, logistic regression. You can do k-means clustering in a deterministic way if you fix the cluster size. It is true that k-means clustering in its native form is stochastic, but you can make it essentially deterministic. It may lose some of its coolness, because if you predetermine the clustering size and the distance between the nodes, it may not learn the best shapes for that data. So you're kind of handicapping yourself, but you can do it. But it's very hard to do it for neural nets because of the things that I mentioned before, is that each one of these weights essentially is taking a random value. And if they're not random, you lose a lot of probability on convergence. And then also you can get these really interesting symmetric convergence properties where it converges, but it converges in a way where you have perfect distribution, equidistance distribution of the classes of things you're trying to reason about. So let's say you're reasoning about dogs, cats, and snakes. Dog, cats, and snakes. And it turns out that in the data set, you have 85% dogs, you've got 12% cats, and you have 3% snakes because people have just less snakes or something. If you initialize the neural net in a way where you don't use random values, you might get a system that appears to converge, but it has an equidistance determination on each of those classes. So 33% of the time it's going to say it's a dog, 33% it's a cat, 33% it's a snake. And so it appears like it's converged, but it hasn't really. So you really want these random values. And because neural networks, at least the way they're being used today, are getting bigger, you need them even more, right? That the likelihood of convergence without them being random is becoming increasingly unlikely. And this has to do with the training of the system, right? We're not even talking about the neural network once it's deployed and you turn things like the temperature down so you try to get reproducible deterministic behavior, which is potentially a possibility, but even that doesn't necessarily work because a lot of the inference that's run on large language models are multi-node, and the way that they return results can be out of order. That out of order receiving of the results can augment the output that you get for the system, right? So there's many different layers of stochasticity that's built into them, trying to get them to be deterministic because of all of these large compute problems is, I would say, in a effective, practical way, is approaching zero. That you could do it, but it just wouldn't be practical. You would lose convergence properties. The systems would be massively slow. For example, part of the reason why we switched from long short-term memories to transformers is long short-term memories essentially had, as far as I understand, many of the temporal properties that transformers have, if not more, but they required serial execution of training. You couldn't train them in parallel, but with transformers you can. And so it was a 10x, 100x speed up. It's some massive speed up in the ability to train these systems when you can do them in parallel, right? But a lot of that parallelism will result in things like stochasticity or non-determinism. Okay, so the key takeaway here is that the Merle AI system, its foundational system is deterministic, that when it finds something, it will find it in a fully repeatable way every time. you may have non-determinism in terms of its execution latency, but not in its output. So it may take 0.5 seconds one time, and then it may take 0.7 seconds the next time. That would be the non-deterministic execution signature, but it's deterministic in the output. The output is going to be the same every time. It sees this as anomalous. It will always see it as anomalous. And that part's really important when you think about Mentor trying to give a score for a repo, that if it finds an anomaly one time, but then it doesn't find it the next time, the system could be confused into thinking, well, did it get fixed? Did that code get just deleted and removed? There's a bunch of things, and then, oh no, it actually just didn't find it that time, and then it found it next time, and then suddenly your score's oscillating, not because the code is changing, but because the darn AI system is just stochastic, and it's like, it's red, it's actually blue, it's green, no, it's red. Okay, so keep this in mind. Now, what does this have to do with anything? Well, my friends, this has to do with a lot. And one of the things that determinism is really, really useful for is hard science. Because hard science has the tendency to be deterministic. I'm not saying all hard science is deterministic. I know quantum folks, I work with some of these people, and entanglement and like quantum coupling, like this is all way over my head. But I have friends that are quantum experts, and they talk about things that are undecidable and stochastic and weird things. I get all that. But the majority of the science that we use today, like arithmetic and mathematics and software code, tends to be deterministic. There are small pockets, again, just to be scientifically fair and accurate, there are small pockets where it can be non-deterministic or stochastic. If you're using probabilistic programming languages, and those exist, it's you kind of want it to be stochastic, right? And even with the paradigm system that I was showing, which is errored out now, it allows you to do stochasticity. It's built into the system, and you just say, like, how much randomness do you want? Because it's synthesizing data, and so you may want randomness, right? But you can control it. Okay, so let's come back to this thing. I found this thing, and I was looking at this, and just for kicks and giggles, I thought, I wonder what Gemini would say about trying to fix this code. And by the way, when I sent this to Gemini, I didn't even really look at this code. I was just like, well, this looks strange. And I didn't look at what Mentor was suggesting as a fix, but I thought, yeah, this is like a little bit complicated and seems a bit unusual. What might Gemini have to say about this? So I asked it. Okay. So here's what I did, is I said, Gemini, propose a fix to this code. And then I dropped in the code, and then it walks through and explains the answer. Then I went over here and I asked it again, the same thing. Propose a fix to this code. Same code. And it proposed something as well. And this answer is different than the first answer. Now, the real kick is, are they both right? Are they both wrong? And why is it that it gave different answers to essentially the same question, right? So there's your stochasticity. And I want us to actually take a little bit of a look at this because, as you can see here, I'm kind of already going to tell you the answer that, no disrespect to Google, but whoops. And keep in mind, this is just, I was just like, I didn't write this code. I was just playing around with Mentor and just playing around like I do. I'm not out here trying to pick on any of these systems. And mostly like I just play around with the AIs every day, like I think you guys do, right? We love these AIs and we're just trying to learn about them to see how they're progressing, where they're growing, where they're not growing. And as I've mentioned many times, it's my strong conviction that these AI systems, in order for them to do hard science, specifically the hard science stuff, their foundational elements must be deterministic. They can have stochastic pieces that are on top of it, totally fine. But the foundation has to be deterministic. And so, like, a very simple example of this is like formal logic. So let's say that you're trying to build a system that can do, I like to play good cop, bad cop, and feed one. Oh, totally. Yeah, absolutely. I actually did this with, I was doing it with DeepSeek and OpenAI. And mostly I was asking some of the funny, just to add more context about what I'm saying. I'm reading what Vair's comment is about the good cop, bad cop. And so sometimes I'll ask them the same question, and then sometimes I'll take the answer and then send it to the other one and say, like, is this right? And then have them kind of like fight each other. I actually just saw, as an aside, this this hilarious thing. It was on the Merly Slack. You can see, like, we have a few different channels that are just like lighthearted and fun. And one of our super coders dropped in this, it's like an Instagram or something, where this guy is being interviewed by these two AI chatbots. And at some point along the way, the AI chatbots get confused and they think they're interviewing each other. And so they start talking to each other. And they're not even paying attention to the candidate. And he's like, what's going on here? And they're like, okay, we'll talk to you on Friday. Okay, yeah, it's great, great interview. It's too, and so yeah, there's look, AI is here to stay. It's not going anywhere, right? But it doesn't mean that like it's done. Okay, I kind of think about it like the early days of electricity. Beef got really mad at me and gave me a oh yeah, oh no, I think I was playing with DeepSeek with Tail. This is before I banned it, right? So we don't use it now for various reasons. Not saying anything about your use, Vair. You do you, but for a company perspective, like no using it on any company stuff. But we were asking it, Taylor and I were asking it some questions, and they were like intentional. Like the CCP probably does not want you to ask these questions. And it was like, I have no information on that. And then next to it, I was asking OpenAI, like, what do you think about Tiananmen Square? And it's like, oh, here's what I think. And then I was asking it some other ones that were sensitive topics that I think in an open environment with more free speech you would get. Yeah, I think to some degree many of the AI, I mean, we know that they're withholding lots of things, right? Like if you ask them how to build, I don't want this to be flagged for bad words, but if you ask it to build something that goes boom, it won't tell you how to do that, right? Like that's also scrubbed from the internet and other things. So And I think if you ask it questions about like other things about harming yourself, it'll be like, no, here's a counselor. So, and some of this stuff I think is good, but when they start becoming like historical revisionists, simply to just promote their own whatever, like this is where I think, yeah, we could maybe do a little bit better. Like, again, we all make mistakes, but I don't know. I'm a big advocate of freedom of speech. I'm a really big advocate of like, this is why, like, I think someone from one of the commenters from another country, T and I are trying to decipher some of them. And there is one where I think this person was saying that I am like a version of HELL. And I was like, I mean, yeah, I could see that. I mean, it's probably not the first time, probably won't be the last time someone has said that, but kind of wasn't expecting that. Like, that's usually I'm breaking up with someone comment. Like, don't just generally get that for talking about how Mentor is going to help you with automated code reviews, but I think that this person really didn't like that. So anyway, the point is I like those comments because I want people to feel like they can disagree, and I'm not going to take personal offense. Like I'm here to engage, have us grow as a community, and we're not always going to agree, but us talking and being lighthearted, I think that's the key thing to building community. So anyway, it annoys me when I think some of these AI systems are censored in ways that are historical revisionists. It's kind of like in the United States when I was a kid, back a long time ago, they used to teach the history of the United States in a very like, Columbus and all those folks, they were just so good and they discovered America, and then they came and they made friends with the Native Americans, and we all had like Thanksgiving together and stuff. And then later on, I found out that that is not actually what happened at all. Now, I understand that at a young age, you may not want to go full truth, but this was being propagated like all the way to like high school. And so I think that it's complicated. It's tricky on how much truth you tell, but saying that certain things never happened when we know that they have happened, like at least from a factual perspective, I think you should be able to have some level of fairness to say, yes, this event happened. It maybe wasn't super great. We're a bit embarrassed that this happened. We shouldn't have done this. We're sorry, but we'll be better in the future. I don't know, something like that. But to say like, no, there is nothing that happened at this event or this day. Yeah. Anyway, I'm going down a bit of a rabbit hole, but we are talking about these AI things. Let me just quickly look at what Bear's saying. Should like a team of scientists and engineers that will. Yeah. I could talk to you about that for several hours, Mur. I usually try to tell like an approximate truth about things, but then like when I was trying to encourage people to just be careful with stochastic systems, like there's like, it's actually kind of funny that the VODs that I put together where I'm just explaining things and I'm explaining in a way that reinforces people's general beliefs. Like I'm explaining how to effectively use language models to capitalize on their spherically constrained stochasticity, or more precisely explained as their geometrically constrained stochasticity. This video gets tons of likes because it's like, oh, thank you so much. This is super great. But in the video where I start to talk about how stochasticity is potentially not great, especially for hard science, like massive downvotes. Like the one where I was talking about Jan LeCun talking with Bill Daly, and I'm saying I don't necessarily disagree with Jan. It's like, and it's all fact based. It's not really. I mean, it's a little bit of an opinion, but we're just talking about the facts of the situation. It's like, no, I'm going to wear these blinders, and I refuse to listen to a scientist that might know something to help me become more educated. The Earth is flat, okay, and the sun revolves around us. So, yeah. I just laugh about it now. When I was younger, I used to have, my ex-wife used to be like, why are people so emotionally bound to illogical ideas? I do not understand this. And then she would be like, well, and she was a sociologist, and a really good one at that. And she'd be like, well, people are emotional. And as someone that, like, I have emotion, but I don't. Yeah, I'm wired differently. So anyway, rather than going down that rabbit hole too far, I want us to look at this example real quick, and we can see that. Is this the? I want to go. What, forward here? Is this the backward here? Backward here? Backward here? Okay. We're just going to go here. All right. So we've got this answer, and this is us asking Gemini how to essentially rewrite this code and propose a fix. And its fix is here. So what I did, here is the original if condition. And here is Gemini's revision. Now, before we look at this, I want us to quickly look at what it says. Oh, and by the way, for any of you guys that are curious what I'm listening to, because I'm always doing my thing, Mur, I think that you may in particular like this one. This is, I'll actually drop it in the chat just so you guys have the name. It's Paladin. I think this is the band. No, this is maybe the song. Or it's vice versa. Hidden Empire. Yeah, I think that's it. It's this guy. Trying to get it to where you guys can see it. I'm just listening to this one on repeat. It's 7 minutes and 44 seconds of just awesome kind of techno. Okay, so I want to quickly read what Gemini writes, because this is actually, I think, quite important in the whole context of weak and strong claims and having like confidence scores on these types of things. So look at this. That's quite a condition. It looks like you're checking various combinations of Boolean flags. To make this more readable and potentially more efficient, we can simplify it using logical equivalences. Here's a proposed fix. So it proposes this, and then I think that is the same as this. And then it explains this. Explanation of the simplification. Let's break down why this works by looking at the original conditions. Now, I want to pause for a moment and talk about this language. Let's break down why this works. So at this point, that's a strong claim because it's already telling you this is right. And I'm going to jump to the end and let you know it's wrong. And that's what all of this stuff is I walked through the logic and I found a case where it is wrong. that this recommendation of this reduction, while compelling, especially with the strong claims and a lot of explanation on all the reasons why this is right, could probably convince a large number of programmers that are maybe not us to believe that it's right. And then we just say, oh, cool. Well, Gemini says it's right. I'm going to just copy this in, paste it. And then what's crazy is that this solution, the part that is the most interesting is that this solution works for like 90% of the cases. Yeah. So unless you have really good tests that are going to analyze all this craziness, you would not likely find the one case that I went through and was able to figure out where it would be wrong. Because I think that that's what I found is there's only one case, or maybe I just stopped after I found one case where it wouldn't be correct. Maybe there's more, but I actually think that it's right for the majority of the cases. And so this is a major issue, right? Because this is part of the reason why we have some trouble with some of these systems is, especially for complex conditionals. This is also why we're principally focusing on conditionals. If it was just an order of operations, like read a file, open up the file, you have a while loop that reads until the end, close the file, it's like, it's kind of hard to get that wrong. But these conditionals, right? Like when you have some wackiness, like this guy, like, I mean, when I first looked at this, I was actually a little confused because I noticed that root being watched is being checked here and here. And then root has value is being checked here and here. And then this thing is inverted. So in this one, it's true. In this one, it's false. But then identity has value is dropped. And so I was like, okay, this is complicated because in this case, what it's saying is all four of these must be true for this first conditional to be true. Then in the second one, it's saying these first ones have to be true, and the third one must be false for this to be true. But it says nothing about this one. So in this second one, essentially, this value can be true or false. It doesn't matter because it's not included. So you can imagine that it's just ANDed with true. But it does require that this is false. So this is a key difference between these two. And then this third one is making sure that this thing is false, and then these other two aspects are true. So what Gemini tries to do, essentially, is it makes an incorrect conclusion. Again, part of the reason why it does this, I just want to add this clarification point. Transformers are not logical systems. At their core, they are not logical systems. This is a transformer. Transformers are made up of nodes, neurons, that have weights, and these wires essentially connect to the next layer's neurons in some capacity, and they trigger usually an activation function, which will transform the value that is being processed by the weight and the input from the prior layer. And then sometimes there's a bias wire that plugs in, but basically it's just a mathematical operation that's being passed through these. And sometimes you have recurrent edges, like in long short-term memories that can have a back edge. But basically, it's just a bunch of mathematics that's sort of moving forward. There's no logic in it. Logic is things like first-order logic, or like predicate calculus or things of that nature. And so it does not have that logical component. Therefore, it doesn't have a foundation of logic at its base. And in addition to that, it also is a stochastic system. So what you really want at the base is you want something that is deterministic. And a big reason for the determinism will become clear in just a second. But you also want it to be logical, if you can. I think you can actually get away with it just being deterministic because the logic can come from the feedback, and then the determinism learns the logical right answers. But it's better if it has logic built in, because then it becomes more automated. It doesn't require humans to manually course correct it and like set the right values constantly. But you could get away with it being illogical or not having a logical component as long as it's deterministic. And the reason for that is very simple, is that in this particular case, and you guys can check my logic here. Maybe we can do this offline, but let's just assume for now that I'm right about the way I broke this down and that Gemini was wrong on this example. The part that's tricky about this is that we can tell Gemini that this is wrong and vote it down. But because it's a stochastic model, the next time it produces a result, it could also be wrong. There's no way to say this is the right result and just use this, because it's inherently stochastic. Now, you could turn the temperature down, but that doesn't get away with the stochasticity that's built in the actual model itself. And that part's, while consumers, I think, are thinking, we'll just turn the temperature down, it's not a problem. Yes, okay, that sort of works for you. The problem, though, is that it's still stochastic in its nature. So then when your AI system that you know and love, they're trying to make it better to integrate all your feedback, right? Because they want to fix the model. It's still stochastic, guys. So when you try to fix the model, it becomes the whack-a-mole, because nobody understands what this thing does. Like, it's a whole bunch of these things, and it's like, I don't know, Bob, just add more data and like cross your fingers and let's see what happens. That's how we debug these things. I mean, literally, that's how we do the debugging today, is we throw more data at it. We like cross our fingers and hope that it gives us the answers we want. And then everybody's like, okay, now just don't touch it. Like, and that's why also it's like, it's not prompt engineering like that. Guys, this is no way to build airplanes. Okay, if an airplane is built on this, I'm not flying on that airplane, guys. Okay. And I strongly recommend that you don't either. Okay. Now, again, I'm not saying that language models, transformers, and stochastic systems aren't cool. They are incredibly cool. I freaking love them. I love them for rapid prototyping. I love them for creative ideation. I love them for stuff like that. What I don't love them for is hard science, when I need the answer to be correct and I need to know that it actually is telling me things that are going to be reliable. And this is part of the reason why we have Merli, is that Merli is designed to actually improve the fidelity of things. That, you know, it takes us longer because we have to actually invent all the technology and build it from scratch. But we're getting there, right? So the part that's, I think, quite interesting about this first example that it gave here, this is wrong. But the second example it gave was right. Yeah, correct is just the best vibe, right? It's like 3 plus 7, like, yeah, it's 9 or it's 12. It's like 9 feels right. Like, both of those are wrong, but it's like, yeah, man, like, close enough, right? Like, don't, if you have vibe coders at the banking institution that you work with, like, switch banks, guys. Just no. Or the hospital that you like, if they start using language models as like their for inpatient form, so it's just time to find a new medical doctor. That being said, if you want to do like a chatbot that's going to argue with you about stuff like this, right? And what's really amusing is at one point when I first started using that, I'd be like, okay, I'm going to be the guy that's going to argue with you, and I'm going to explain to you why this is wrong. And so I would be like, no, you're wrong. And then I would explain it to them, and then it'd be like, no, you're wrong. I'd be like, do the logic. And then I would finally convince it. Mostly I think it's just trained to eventually agree. Like, I don't think it actually knew that it was wrong. And keep in mind, I'm not the guy that is going to argue with the AI when I know I'm wrong, just to see if it will switch to the wrong answer. I know some people are doing that, but I would do it because I would try to help the AI. And then I realized this is total, like I am a missionary. Like, this is why, like, for example, Taylor and I have the board meeting tomorrow. I was probably doing board related stuff, but yeah, like, nah, I would rather do this. So sorry, board, if you're watching. Look, GDT is good for the company. Anyway, so it comes with these two answers. And again, given this is identical input. I said the same thing twice. Propose a fix to this. I dropped in identical code. It gives a different answer, which is part of the stochastic piece, which is awesome if you want it to act strange. But when you want it to act like a calculator, you really want it to give an answer that is deterministic, not stochastic. And the big reason why, this is the most important reason why, is then when it's wrong, you can say this is wrong. And when it's right, you can say this is right. Use this answer. And you can do that with deterministic systems. Deterministic systems, because they are deterministic, it's going to say, for example, that this is an issue. Mentor is going to say this is an issue. Now, there used to be a way where you could interact with this and say, this is not an issue, Mentor, you're wrong. And then Mentor would take that feedback and say, okay, I was wrong. I am now going to learn from this, and I will not give this answer anymore as something that's an issue for anyone, as long as they have the authority to do that, right? You could do it for, like, if these guys did it for this repo, if they're the repo owners, they could do it for that. Sweet. They could do it for that one repo, but then they would need like a higher order person to come in and say, is that correct for like all repos, right? So there's like a hierarchy of trust. Think of it as like Stack Overflow. But the point is that with deterministic systems, you can learn, and then when you finally learn the right answer, you can say, that's the right answer. And then it knows, and it will give you that answer every time. Whereas with stochastic systems, it doesn't matter how many times we tell it, yeah, that's right. Oh, that's right too. Because the stochasticity is built in, it's going to give you this, like, again, there may be parameters depending on how you build it to try to trust this, but it's fundamentally a different thing in that you could continue to go down this rabbit hole. And even though you have things that are correct or you have things that are incorrect, it still does kind of whatever it wants. So I wanted to share this with you guys so you could see a concrete example of what I'm kind of talking about when I am explaining how we really want determinism for hard science, for most of hard science, and that stochasticity can be really good. Like, we use a form of stochasticity for Mentor when it's giving these answers. Oh, I forgot to mention that I went through Mentor's answers, all 4 of them, and what I saw is that, and I'll try to like double check my logic, but what I saw is that Mentor was right all 4 times. And keep in mind, the reason why Mentor gives you 4 different answers, that's on purpose, because it's trying to solve the problem differently for different domains. So if you have more of a security focus, it's going to try to solve it in a more secure way. If you're more performance focused, it's try to be more performance based. Some people care most about readability, like this guy. I actually argue that readability is more important than correctness. I think I talk about this in one of the things. And then another piece is like modularity, designing things that are super modular, so they're easy to extend. So this would warrant potentially different solutions. This is not done because Mentor thinks it's wrong. Mentor is doing levels of validation through its logical system each time. So this is using a stochastic system initially actually it's using multiple stochastic systems. And then it's trying to essentially apply a logical constraint solver to ensure to some degree that these answers are correct. Now, the logical constraint solver is not guaranteed to be like fully correct, because that problem in and of itself is somewhat intractable. I mean, you could do it and it would be guaranteed to be right. It just might take you 100 years because it has to reason about the whole program. It would have to actually like do an execution. And so like we don't do that yet. Maybe once we have quantum machines, we can start to do this type of thing. But notice that because Mentor is built on a deterministic system that has logical constraints, like we have a semantic reasoner, that then when we're producing answers that are higher up, that are like these stochastic things, Mentor can then have a lower form of validation that it's, just to be clear, it's not guaranteed that this will be right. I want to be super clear. What we've seen is that most of the time when Mentor flags something like this, it's right. Like for example, Gemini it's infinite wisdom. While it didn't get the answer right in this case, the other example it did get right and it did reduce it. And so Gemini like also agrees, oh, there's a better way to write this. So that's what Mentor's found is that. And this is our deterministic AI. This system, it will find this issue every time. Every time it'll find this issue. You could delete this repo entirely, or you could download Mentor right now and add this repo. I promise you, it will find this every time. This might be different because this is some level of stochasticity. Jack, I love you, man, and I appreciate the stuff about religion. Talk about religion all you want, but just let's try not to spam. So 3 or 4 times, that's good enough. We'll keep it at that. Otherwise, T may have to silence you. So yeah, awesome. So I want to share that it does have the logical analyzer and it does semantic reasoning. So it increases the confidence of its correctness, but it's not guaranteed to be correct. Not yet, anyway. We do have other aspects that are likely to improve that. And part of that is the reinforcement learning with human feedback. This is also just a confidence score. This is, if I'm being completely honest here, this is a nines problem in my mind. I don't see a practical way that you can ever do code synthesis from an AI that is not doing a full logic constraint solver, which is not AI. That's a formal logic system. And it uses different methods because that's a constraint solver. It uses logical reasoning to determine its correctness. AI systems are more like speculative and probabilistic in nature. So it's my strong conviction that any AI system that by definition is probabilistic will never be able to say with 100% confidence that the things it synthesizes is correct. But I think we can get it to be a nines problem. I think we can get it with some degree. We can say it's 99 point, very much like what we do with databases, right? Databases can't say this is perfect. It will never go down. It will be all reliable, all this stuff. And the truth is, the database systems run our financial institutions. They run our power grids. They run a lot of other stuff that's super secret, right? And so the world of science as we use it today is not perfect, but it approaches a level of trust with nines problems. Like, for example, while airplanes generally are the safest way to travel, sometimes bad things happen with airplanes. And so like we had the BO BOENG, something like that. That one, I'm intentionally not saying the word. I'm learning the tricks of the trade. But we had the issue with that aircraft manufacturer, and so these things happen, right? Sometimes there are bugs. So I don't know that we'll ever get to 100% confidence. I think that some people that are misguided will often say that we will. Like, I've seen actually. Okay. All you guys know, I don't. I never try to really pick on people. I don't, because that's not great. But I do get kind of annoyed when people are really loosey-goosey with their strong claims, like what Taylor's pointing out. Oh, and by the way, Mur, what did you say? But Goju, I built a totally awesome aircraft with laser and all embedded in airframe. Yeah, man. Yeah. Yeah, like that's what I'm talking about. Yeah, buddy. Vibe it away, my friend. Vibe it away, Mur. It's a little bit scary. So, what was I talking about? I think I was just talking about the lack of the. Oh yeah, it was the 100%. So, yeah, part of something that I saw in like the early days of machine programming for commercial use. Because keep in mind, I've been doing machine programming since like 2016 as an active research area when I was doing this in Intel Labs. And then it was around 2020 or something that like the GitHub Copilot stuff started happening. And I would see them make these claims. I actually even saw AnySphere Cursor say this, is that they're going to build a system and it's going to replace all coders. Like, coders won't exist anymore. So first of all, like, I don't know if that's necessarily the right marketing strategy, guys. Like, even if that's what you believe, the messaging there might not be super great because your target audience in a lot of cases are coders, right? So, like, if you are trying to get coders to use your stuff to be more productive, maybe not tell them that your thing is gonna eliminate their job. Like, I don't like, I'm not a marketing person. What do I know? Right. But I might start with that. So I thought that was pretty funny. But the part that I think is funnier is that I have heard these jokers. And again, I'm not going to mention any names, although I know the names. I have heard them go on record saying, yeah, there won't even be coders in 5 years or whatever, and we're all cooked. And now, if you look at what they're saying, AI will never replace coders. AI is never going to replace developers. Like, we're always going to need, and it's fascinating to me, that transition. Like, I think a more, and I'm a scientist, so maybe I'm being a little pedantic here, but I think that there's a way to answer questions in the media that explain that you're not sure. You just don't know, right? There's not enough data. And again, maybe this is the scientist in me is... Yeah, I hear that that's like... Yeah. Oh man. Oh, Mer, you're taking me down these rabbit holes. Yeah, you know too much, my friend. Yeah, the did you guys know, just as an aside, not many people know this, but Sam Altman, the fellow that runs OpenAI, I guess today, he used to be the president of Y Combinator, and he was fired. Like, he didn't resign; he was fired from YC because he illegally tried to take control of their board as, I believe, the chairperson, which he had no business doing, and so the board fired him from YC. You guys can fact check me on this. Actually, you know what? Let's do it together. Let's see if I'm making this up. Was Sam Altman fired from YC as its president? Oh, he wasn't. Okay. Oh, 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 I'm sorry. He stepped down. Okay. Let's read this. No, Sam Altman was not fired from his position as president. He stepped down to focus on his role as CEO of OpenAI. Okay. Okay, guys. So here's okay. Now let me be fair for a second. Oh, look at this. We have this is fascinating. Okay, I think the part that is really fascinating is there is this. Like, check this out. On May 30th of 2020, like, because Forbes never says anything that's not like when they were talking about Elizabeth Holmes being like the next Steve Jobs, like, yeah, you guys nailed that, right? Okay. And I think that they also were saying things about Sam from FTX being another superstar, and I think that he's in jail now. But anyway, there's a very interesting kind of parallel here. Is why is it like here? Let's get on this rabbit hole a little bit. Why is it that? Oh yeah, I'm curious to hear what Perplexity says. Why is it that if this happened in 2019, that Forbes would be writing an article about this in 2024? Like, why would Forbes care about this? Why would they care about sharing that Sam Altman was not fired from from Y Combinator? Like, what relevance does this have to Forbes? Or instead was like, look at all this stuff. Look at this. Like, this is quite fascinating. Claims Sam Altman wasn't fired, and so all. Oh wait, no, he was fired. Okay, cool. Yeah. So, before Sam was fired. Oh, okay. So look, here we go. These guys in 2023. Okay. So let me share something with all of you that I suspect that many of you, like, I know that Mer knows, and I know that T knows. But for the larger audience, I want to share something that some of you may or may not be aware of. When you reach a certain level of being an executive in industry, when there is a sort of vote of no confidence in your leadership, the board will often give you the option to resign, so you won't tarnish your public image. You will be fired if you don't resign, but most people opt to resign because then it doesn't hurt their public image. And part of the reason why this is done is that when you get people that are like at the executive level, they oftentimes end up being people of influence, even if they're not like super successful in whatever your thing is, right? That's why you'll often hear that this CEO stepped down or Sam Altman stepped down, right? And good on YC or whatever this is to control this narrative, because they probably really want to make sure that their buddy is going to work with them, since he's rolling in cash right now. And oftentimes, I mean, like, what does YC care about? All right. Like, do they care about the advancement of technology and all that stuff? Or do they care about like finding the next unicorn? And like, I'm not trying to be not fostering goodwill. I'm just trying to speak more transparently about, like, I don't know that these guys are professors at the university that are taking really like small salaries and trying to advance the, technology and science and educate the world to make everybody better. And I'm not saying that VCs are bad people, but I think that different people have different agendas. And I think that that's important, right? Like, for example, I'm not the kind of person that goes to nightclubs and raves. People can do that. It's just not my thing, because my agenda is science and technology. That's what I want to do. So that's what I do. And so VCs, oftentimes their primary focus is to make sure that they get a return on their money. And so if you have high-level people that are going to be running into a huge amount of money, you might not want to burn bridges with them. So I find it very interesting how around this time last year, there's suddenly a bunch of comments about, like, isn't this strange, guys? Like, keep in mind, I used to be the spokesperson for machine programming at Intel. I know a thing or two about like embargoed stories and the way that these legacy media things work. So when you have a story like this and it comes out on May 30th of 2024, and then you have another story from TechCrunch that comes out on May 30th, 2024, and then you have another story that comes out in Business Insider on May 30th of 2024. Huh. What a coincidence. I wonder what it all means. So anyway, I guess I was wrong that Sam was not fired, that he stepped down, and cool. I would actually love to know about, where is the Wikipedia? Yeah, okay. I would really love to know about the chair. Huh. Yeah. So interesting. So this paragraph here, in March 2019, YC announced Altman's transition from president to a less hands-on role as chairman of the board, allowing him to focus on OpenAI. This decision came shortly after YC announced he would be moving its headquarters to San Francisco. As of early 2020, he was no longer affiliated with YC. This is quite interesting because there was a version of this Wikipedia entry, probably that existed as of last year, that told a very different story about what happened around this time frame. And it appears that that has since been revised. Now, I think that the part that maybe is even more curious is, as I understand it, Wikipedia is supposed to be Who is Sam working for, and why did he try to take over YC? Is what I'd like to know. Yeah. Yeah. Very interesting. We'll get into that in a second. One of the things that I think is very interesting is that Wikipedia is supposed to have these fact check things, and I know that it's very hard, right? Like getting this stuff. Oftentimes, when I teach at the university, if I'm doing sort of like a low bar explanation of something, I might use Wikipedia just as like, I'm just lazy. Here's what Wikipedia, but don't actually trust this. Like it's not a true source of truth, of trust. You should find like peer reviewed publications because they will get some of the definitions wrong. But the fact that they're trying to be quite factual and they have revised this now is quite interesting. But I do have to say that given the articles that we just saw that came out last year around this time that clearly have stated in a very public way that he was not fired, then people could try to claim this as evidence that substantiates the fact that he was not fired. And so I can see that they could revise Wikipedia now given this new emerging evidence, which may or may not be part of the truth. Yeah. So anyway, I think that's maybe enough about that. It's just oh yeah. So the reason why I went down that rabbit hole is Sam and well, I think it was the GitHub CEO and a few others that were saying the language models will write all code in the future. There won't be coders. Almost all of them have backtrack now, and that's cool. Like in some sense, I appreciate that the Wayback Machine. Yeah, I appreciate that they are walking those claims back because better late than never. Truthfully, I think that that's fantastic. But it probably would have been better to maybe just qualify the claim and kind of do what I'm trying to do, which, and not to say that I'm doing this the right way. Like I make mistakes all the time, but like I'm saying over here is I have a strong conviction that we will never get to 100% correctness here. I just, based on what I know, I don't think that this is possible in a practical way. As much as I would like it to be that way. That's my goal, is that this would be a closed loop system, and then the MP systems could write a huge amount of code that we have incredible trust on, and that's amazing. Unfortunately, I think it's harder than that, and we're going to need humans to help us with this stuff. And my new take actually on vibe coding is that vibe coding is actually a mechanism to increase the volume of developers, because I think we're going to start producing so much code with such low fidelity that so many people don't know how to maintain, that the need for people that actually can understand code will increase, not decrease. That's my new speculation. And it seems to make sense to me because I know people are doing this vibe coding thing and they're getting to like these prototypes, but then they don't understand what it's doing. So then they need to hire someone to help them. And so they're like, vibe coding is actually creating engineering jobs for us. So go vibe coding, go, right? Like that's fantastic. You guys go. You can do the prototype stuff and then hand it off to the human engineers that can code, and we can make it production worthy. Like we can improve the fidelity. And in fact, that's actually one of the things that we're starting to explore with some of the code assistant folks. Not all of them. There are certain ones that my moral compass is I'm not going to allow money come in the way of my integrity. I will not do it. If I end up dying totally poor and broke because of it, that's just how life plays out. I think that we're going to be fine either way, but I don't need to be a billionaire. I have zero interest in that. I think that's actually super boring. And so there's certain code assistants that I am really not impressed with on the way that they're doing business. It feels very unethical, and we're actively choosing maybe not to help them. Whereas other ones that we do like our friends at IBM with What's Next Code Assistant. Again, not saying IBM's perfect. Nobody's perfect, but I know details about how What's Next Code Assistant is being trained. I know the team. Taylor and I met the guy that actually runs all of them when we were at Boston. They're great. I like what they're doing. They're trying their best. We're looking to work with them and potentially others. But if they're super unethical and they're trying to do just an insane money grab, and they're selling lies and saying that these things can do things that they can't, and just trying to, essentially make as much money as possible and then get out of it, I'm not. I have better things to do than to. There's a lot of people that need help, and I'm going to choose to help the people that have similar levels of integrity. I don't. There's not such small number of people that need help that I need to help the mercenaries. Other mercenaries can help those mercenaries. Okay, cool. So let me take a quick look at the chat here. I think we had. Oh yeah. So I don't actually know all the details about Sam with the takeover of YC. I do know that there was, for a very long time, the perception that I think it was after he sold his first startup that he got involved with YC, and then he became the president of it, and then tried to illegally take control of the board as the chairperson, and then was fired. But clearly, based on what the internet says today, that's not what happened. So we will say at this point, I've seen it told both ways, and who knows? But I am pretty seasoned in how executives are often, unless it's really, really dubious, they are often given the opportunity to resign from their executive positions. Because if they get fired, right, then usually that means their career is kind of over for, like, who's going to pick them up? And so there's sort of this, it's sort of like the difference between what people think happens in the real world versus what actually happens in the real world. Is that I think people have a perception that the real world it's super perfect and everybody is on the up and up, and what you read in the news is exactly what happened. And then as you start to see the inner workings of the machine, you realize it's actually far more nuanced. And to be honest, I understand why it's done this way. Is that it is, for example, with Pat Gelsinger stepping down as CEO of Intel. Was Pat not doing the right thing for Intel? I don't know. I don't know enough about it. I have met Pat Gelsinger, and I know that Intel was pretty excited about him being involved, and I think he was trying. And so, yeah, I mean, I think him being able to exit and save grace, I think is that's good. I don't know that he's done something super malicious. And so that tends to be what's going on. But when people are doing super malicious, I mean, even in those cases, oftentimes you'll hear that this person has resigned due to like when you hear about like senators, that there's this public thing, and then the senator has stepped down. Like it's really that they like who wants to give up that position. I mean, if you get elected as a senator, which is a very, very hard thing to do, and it comes with incredible amount of power that you can wield across, like at least in the United States, across a number of vectors. This is something that I think most people that are trying to become a senator are not going to give that up. Like, for example, the fact that I'm at this university, like, unless they tell me, Goju, you can't be here anymore, I'm not likely gonna be like, hey guys, I'm stepping down from this position. Like, why would I do that? Right? It was not super easy to get there. I really like the people that are there, and I learn a lot. Like, I'm very grateful for it. So anyway, we're really meandering, and we're over an hour 40, so I think that we can wrap this up for today. But hopefully we got a good example of why you want determinism in your machine programming systems. And this is one concrete example. I also want to say that it is a little crazy that like Google is like a $3 trillion company. And Merle isn't. I'll tell you that. I think we're probably not. I don't know if ever, but I think that this is why I think there's comments about how almost all forward progress in the world is happening from startups. Is that I think that there are people that do startups that they are mercenaries and they just want like money, and that's fine, no judgment. Like, people can do whatever they want, but I think there are also people that do startups because they have deep care. They really like. I think about Linus Torvalds. Like, this guy I think has incredibly deep care. And does he message things perfectly? No. Like, I don't message things perfectly. I've seen, like, for example, the MIT article that it's even from my good friend Will Heaven. He didn't include the full quote about my dog. I said what I said is that I was trying to give an analogy on how there are cognitive constraints. Yeah, exactly, T. There are cognitive constraints on different systems that then can inhibit their ability to reason about more complex things. And so I said, for example, I love my dog. We named the company after my dog. Our mascot is my dog, right? Like this. Oh, well, yeah, this thing, this is like, actually, he's not blue, but I mean, you guys have seen him. Like, we modeled it after him. Okay. Like, this guy is my little partner in crime. So I said all that. And then I said, but there's no amount of training that I'll be able to give Merle so he can code in C++. And what Will said was, and Justin draws a very clear like distinction on the cognitive limitations, using the analogy that no amount of training will make dogs be able to program in C++. And I'm like, okay, now everybody thinks that I hate dogs, right? I'm like, Will, buddy, like, come on, just add another 2 sentences, man. Like, throw me a solid. I mean, I'm surprised I didn't get like a whole bunch of hate mail after that. So anyway, I think that there are missionaries out there doing startups, and I love that. And I know some of them. And I think that together we can do really incredible things, and we will push things forward. right? Like we'll push things forward like this, and then minimally, then we can advise. Like I actually have, I'm not going to mention the name of the company, but it's one of those like $3 trillion companies. There's not very many of them, so you can use your imagination. But we have a deep dive meeting with one of their senior technologists on how they might be able to use Mentor and Merly Tech to make their software development better. And so, yeah, we're working to help these folks, and I'm pretty excited about it. So we've got a ton of work to do. We're nowhere near finished. We're literally like at less than 1%, but it does give me warm and fuzzies when I start to see that you can have a $3 trillion company that is public facing and has decided that it's willing to give this, and then this piddly little, no name guy can come over and solve the same problem and actually have like potentially better fidelity. It gives me hope that the little guys can actually move things forward. So anyway, folks, I think that's it for today. We will circle back next time, maybe tomorrow night, and talk a little bit about abstract classes, pure interfaces, and versioning. One quick tidbit before we hang up. If you do versioning and interfaces, strong recommendation. Build the versioning unit as the first parameter for the API. Always do it. There's a very specific reason for this. And the key thing is that the interface could have variable amounts of parameters. And so if it's always the first, then that tells you how many parameters you're going to be reading. And then you can support variable parameter lists. There's like a specific name for it, but the whole ... But if you don't make it the first parameter, then you can't necessarily do this. Oftentimes people will, this is why I'm saying that if you don't build versioning into your interfaces from the get-go, you're already cooked. Oftentimes people think that I'll just add the versioning as the last parameter. This doesn't actually work. At least it's more complicated. And the reason for that is if the parameter list has to grow, then you don't know when the last parameter will be there. Whereas if you have it be the first parameter, you always know it's the first. You read the version tells you the size of the parameter list, and then you do things. Yes, there are ways to make this opaque. So you have a single opaque parameter type as the first parameter that contains everything. But that's maybe not. That can be a little bit of a kludge as well. So I still think version first, and then if you want to use the opaque thing, have at it. Anyway, thanks, GTTers, Jeters. You guys are awesome. Mer, it was great having you chat with us. T, thanks for hopping on, and I look forward to chatting with you guys next time.